Welcome to another episode of the Cool Tools Show and Tell. Our special guest this week is Will Walker. Hey, Will, would you like to introduce yourself to our audience?
Yeah. So my name is Will Walker. I've had a really strange career. I started out getting a degree in painting and have gone through the process of being a maker. I've co-founded a business making exotic ceramics. I've made ceramics myself, and then gradually moved into product design. I've designed a sneaker and also worked on how we interact with computers. And so today I'd say I work on human computer interfaces, primarily how we talk to computers with our voice. And what are all the little signals that we give computers that they don't understand yet?
Cool. That's going to become very important because, as you know, we've entered into the period of having a conversational user interface to the AIs instead of graphical user interfaces. So that conversation is going to become more and more important. So I'm so glad you're working on it.
Yeah, I think it's endemic, or it's kind of this interesting fact that even if you could, perfectly talk to these large language models or these AIs, they wouldn't understand 60 to 70% of what you actually mean because
Right.
they don't understand where you're looking, they don't understand your tone of voice, they don't understand your emotion. And so until those problems get solved, until we really understand that, we really truly aren't talking to our computers yet.
Yeah. But we will be, of course, but I'm so glad you're working on the case. So, Will, what's one of your favorite tools that you'd like to share with us?
Oh my gosh, so many. I think the first one is a class of tools, and it dates back to the first startup I was ever a part of. It's called a supercritical dryer. And a supercritical dryer is just a high pressure vessel that allows you to heat up different materials and pressurize them. And in particular, with supercritical drying, you're heating up liquid carbon dioxide. So, why would you want to do that? The reason is because it allows you to make a class of material called an aerogel. And aerogels are the lightest solid ceramic materials you can possibly make. They're also really cool because they look like pieces of the sky. It's like you're holding a little tiny piece of the sky in your hand. So I'd encourage anyone who hasn't seen an aerogel or touched an aerogel to Google one. They've been, commercially available since the early 2010s. Before that, you had to kind of get them from NASA or some other large lab. And I got involved with them as an artist because I was interested in using these materials that look like the sky. So let's go
Okay.
back to
So just a second. You
yeah.
said if anyone hasn't. I have not touched one.
Mhm.
Where would I go to get one?
Oh, well, so to learn about them, you can go to a website called
No, not to
Aerogel.
learn about them. I mean, no, to hold one.
Oh, it's a whole one. So there's a company that actually sells them, Aerogel Technologies,
Uh-huh.
and that was a company I helped to get off the ground. And
Okay.
they're still selling them today. They sell little pieces that you can kind of explore and you can pick up, and they have all different kinds of classes of them. Some of them
And
are,
and and
yeah.
and besides using it for art, are there any practical reasons? Would someone, eh, what would I or someone else buy one for in terms of its utility?
Oh, well, they're the best insulators that are solid.
Wow.
So you can
Okay.
actually um, use them in a very tiny space to isolate a very big temperature differential. So
Okay.
you want something really hot next to something really
Right.
cold. And one of the places that this really shines is when you have an aerogel made out of glass or silica, because it can handle a really high temperature like a direct flame, and you can put that against something that you don't want to burn.
Okay. So let's go back to the supercritical dryer. Um, so this is a tool that you're suggesting. Can you describe this tool? Like how big is it? What does it look like? What does it do?
Yeah, this is it's kind of funny because it's a variable size and shape. Um And the larger they get, like any pressure vessel, the cost just goes up enormously. And even small ones are expensive because they have to be able to hold 1,000 pounds per square inch of pressure. So there's a lot of steel, and you need a certified, pressure vessel that
Yeah.
holds that pressure in.
Okay.
And
So let's say that I have one.
Mhm.
Besides making some aerogels, is there anything? What else could I do with it?
Yeah, so you can actually decaffeinate coffee with it. Or
Mhm.
you could dry clean your clothes. When you send your clothes off to be green dry clean, they actually are using a
Right.
supercritical drying process to clean off, and it's essentially a solvent that washes away anything that's an impurity.
Right. But that sounds pretty big if I can put my clothes in it.
Yeah, that's
Um,
going to be very like large and
what could you do with a small one?
Oh, well, so you could take like a small piece of like a gel, like a gelatin, and you cast some jello, and you would put it into the supercritical dryer, and then you add liquid CO2, and you heat up the liquid CO2 until it's actually not even a gas or a liquid. It's a supercritical fluid. And at that point, you can slowly let the pressure off, and the CO2 will come out, and whatever liquid was in your gel disappears. It's evaporated with the
Mm.
CO2. And so what that leaves you with is essentially the skeleton of the gel. And so you're left with this material that's very airy and porous and
Hmm.
has these very, very small pores, and is unlike anything else that you could create. So it's a very specialized tool, and not, I wanted to go for something that was really unique and probably hadn't been recommended on this
Sure. Yeah, that definitely
podcast
has not been
before.
recommended. Yeah.
Yeah,
And I imagine maybe some of the molecular gastronomy kind of a high-end chefs would kind of play around with this kind of stuff.
exactly. One of the first things we did when we were testing out a supercritical dryer that we built was to dry Jello and then to taste it, and it kind of had this like popcorn slash super dry. It just like stuck to your tongue because it was so dry and had such tiny pores that just wanted to soak up all the liquid in your
Mm.
mouth. So it had this like suctiony feeling to it. And then as it goes, it sort of collapses the way that a popcorn or like a chip might collapse in your mouth, but like 1,000 times drier and lighter.
Wow, wow, wow. Um, and so how is it? How is the sort of result different from freeze drying? Because you
Mm.
mentioned liquid, solid COT, which is very, very cold. So
Mhm.
is there a difference between freeze drying and then supercritical drying?
Sure. So I'm not as familiar with freeze drying, but supercritical drying is unique because it helps you get liquids that might cause capillary pressure. When a liquid wants to leave a pore of a material, it exerts a force as it's exiting, and that tends to collapse the material. So if you were to take Jello in your fridge and just leave it there, you're going to notice that as time goes on, it sort of turns into this shrunken little like dried out husk. And that's because as the water is evaporating out, it's leaving, it's collapsing or causing the pores inside the Jello to collapse. And so if you're able to use a liquid to take it out, and in particular a supercritical liquid, the supercritical fluid has essentially no surface tension, and so it doesn't exert that same force, and so your material essentially stays fully inflated as
Yeah,
the liquid, and it's as you remove the material and lower the pressure, the gas is still inside the pores. So
right,
the
right.
idea is that you're going from a fluid to a gas in a very smooth and gentle
Right.
process, even though the temperature is high and the pressure is very high.
So we get these freeze-dried strawberries from Trader Joe's for our granddaughter that would seem to retain much of their shape, and they have this aspect where they're kind of like everything, but they're just without the water,
Mhm.
and they have a kind of a crunchy, odd texture and an
Yeah.
incredibly intense flavor.
Yeah. So that's I think the difference might be is that the strawberry that you get from a freeze dryer is probably like 60 or 50% of the volume of the original strawberry, whereas an aerogel would be like 90 to 95% of the volume. And that makes a big difference in terms of the porosity and the ability for a material to really insulate.
Okay.
So these are like subtle things, but they're sort of hardcore material science questions, and they sort of unlock these magical properties about materials that you can't really get any other way.
So going back then to the supercritical drying tool,
Mhm.
um, do you have a recommendation of one, and how much do they cost?
Oh, well, they're expensive. They're kind of in this class of, if you have to ask, it's too much. Mostly they're bought by manufacturing facilities. Even the computer chip industry uses them a lot to clean things very carefully. But there's actually a website, an open source website called aerogel.org, that actually has a description of how to make your own supercritical dryer from scratch. And really, what you need are some high pressure plumbing fixtures,
Right.
which can run in the like low thousands of dollars. It kind of depends on the size you're going for, but essentially, you're looking at like a tube with like a boltable, couple of holes in it and a
Yeah.
boltable exterior caps.
Okay. So if you can make it do it yourself on your own, why are they so expensive?
Because of the need. So when you do it yourself on your own, you're probably like ordering some gas from like a plumbing supplier, or even from like a company that would supply restaurants. And the professional ones, they're automated. So they have a computer control system, because you really, anything that involves this kind of pressure, you have to babysit these things, and you have to be there, and you have to construct, a safe enclosure around it. And that is all outlined on the website. So, you need to follow a lot of safety precautions. This is a like big time grown up in a workshop, type of activity. But it's really quite exciting, and it's kind of magical. You can like be an alchemist who creates a completely new form of matter. So I think it's just kind of this is more of a, like I said, on the like spectrum of like very odd tools.
Okay. Um, well, it sounds like this is kind of one of the kinds of tools that you may not actually ever use, but it's good that you know that they exist, because they
Yeah.
might at some point for somebody open up a possibility that they didn't even know was possible, and that's what this tool is about.
Yeah. And I think for me, the tool was a pathway. So some tools you buy because they give you this general purpose utility. And this was like a pathway as an artist where I wanted the lightest solid material.
Yeah.
And so I was like, I'll do anything to get it. And eventually that led me to the tool. So
Okay.
sometimes, on your path, you have an end goal in mind, and then the tool gets you there.
That's fantastic. Okay. Well, that was really great. It definitely was a tool we had never heard before. Although there were a couple other tools and cool tools that have been nominated for the high-end restaurateurs and chefs who are kind of exploring the edges of what's possible. This sounds like it should be in their toolkit too. So, Will,
Definitely.
what's the second? What's number two on your list of
All right.
cool tools?
Okay. So this is also a very, I think, kind of odd tool. It's called a Paint Shaver Pro, and I'm sorry, I'm going to just pick it up really quickly so I can reference it as I talk about it. The reason I bought this is because, again, like the tool is dictated by the task. I'm restoring a 1890s Victorian house, and one of the problems you run into in those houses is plaster. So there's a lot of plaster in these old houses, and plaster is a really interesting material. Talking about materials again, it's very heavy. It's made of sand and limestone. And in many cases, what people will do is just destroy it. They'll just knock it down off the walls and throw it away. And it's a huge, it's a huge carbon sink, because you have to throw away all the old materials, you get new materials, and you lose a lot of these properties of this plaster, which are sound insulating. They're, it's very low risk of fire, and it's just kind of this beautiful original material. And so how do you restore it? And that's where the Paint Shaver Pro comes in. And this is a tool that's made in Rhode Island by a small family firm. And what they do is they take a grinder, essentially like a carbide tipped grinder, and they have this carefully machined attachment for it that allows you to hold the grinder at a very precise angle from a surface. And so the original purpose of this was to strip paint from clapboard side houses in New England, or even to strip like gel coats from boats, old boats. And so what this does is it lets you hold this grinder at a set angle, and you kind of run it along the side like you're trimming like a hedge, or and it takes off about 3 to 5 inches in a pass of material.
Uh-huh.
And there are these little carbide blades that sit on
So
the
you're holding up this handheld tool that has it's plug in, and it's got as you said, it's kind of like a grinder, angle grinder, but instead of having a disc where
Yep.
the grinder would be, there is a contraption. There is kind of an aluminum
Yep.
a face, and there is this recessed triangular rotating set of three cutter blades. There's a cutter blade going around,
Exactly.
and
Exactly.
and you have two handles. So you're putting this up against the face that you're grinding, and instead of it kind of grinding, it's cutting with the three routers or three cutters.
Yep. So I went through a lot of failures trying to figure out how to restore plaster walls. And the first failure was just paint scraping with my hands. And that was slow. And there were, hundreds of years worth of paint on the walls. And I needed a way to get like the dust off, and the paint chips were going everywhere. And one of the nice things about this is it has a vacuum port.
Right.
So you can actually attach a dust extractor to it, or a vacuum, preferably something with a HEPA vac. And you should use this. Definitely wear a mask, like a very safe respirator mask with it, because you're kicking out a lot of dust and possibly lead paint dust. But what this lets you do is take off all of the paint in one pass and get back to that original surface without disturbing the surface underneath.
Right. Okay.
And
So the crucial thing is that you're restoring a plaster as is the wall. So you're just kind of going to keep a plaster wall and restore the surface to make it paintable again, or
exactly.
whatever it is.
Well, I mean, the interesting thing about plaster is that it's this limestone material, and it's actually become very trendy, or like very hot, to use lime wash paint to recreate the original look. But that lime paint is not very compatible going over old acrylics, or whatever paints existed, have been put on in the last 100 years. So by going back to that original surface, now you can paint the original paint, and you get this beautiful matte finish. And it's basically can last forever as material. And if you go to a lot of the like YouTube videos about this, are people in Britain or in Germany who are like restoring rather than discarding. That's kind of an American thing. We have to like rip everything off, throw everything away, put in the latest technology, and then 10, 15 years, it's worn out and we have to do it again. And that really doesn't sync with my idea about how we can build a sustainable culture.
So going back to the Pro,
The Paint Shaver Pro. Yeah.
Shaver Pro, it sounds like can you also use this for removing paint?
Oh yeah. That was its primary.
Right.
The weird thing about this recommendation is the company didn't really recommend it for this. I tried a bunch of different things.
Right.
And this worked the best. So, you can strip maybe half a room in a day if you do a full day with it. Yeah.
Well, but it's also a paint stripper, is what you're saying.
Yeah, exactly.
Well, to me, that's more interesting, because I spent my high school summers painting houses, which means that you spend 3/4 of your time taking the paint off the old houses, and I hated it. We were doing it by hand.
Yeah.
And we didn't even have sanders when we had like sandpaper.
Yeah.
And so this would have just transformed that if we could have just gone along with scraping it off with a power scraper.
Yeah.
So, that sounds fantastic.
It is. Yeah, that's the primary use. And in fact, I think a lot of people will buy this tool, and they will use it as a business, and they can get like, because it just transforms how fast you can take paint off of
Right.
surfaces.
And can you adjust the depth at which it's shaving?
Exactly. It goes from 0 millimeters to 2.5 millimeters, and
Right.
it's really designed to just scrape. And the other thing that's nice about it is, um, it has two angles. Talking about taking paint off, you have these old clapboard houses, and it not only takes off stuff on the long flat surface of like, let's say, some siding, but it also has this top that's open, so you can also take off the material underneath the corresponding facing.
Right.
Yes.
The overlap part.
Yeah. Yep. So
Wow, that's awesome. So you began by saying that it was made by a family one. So does that mean that there's really only one, or are there other versions of these rotary paint and scrapers available, and this is the best, or how does that work?
yeah, this is definitely a specialty tool, and the family that made it, they charge a premium. It's a very they charge, I think, $1,000 for it, which is
Okay,
quite expensive unless you're actually thinking about how long it takes to pay somebody to do this work.
exactly. Right. If you're painters today, I mean, you around here you can't get a house painted for less than $10,000.
Exactly. So this can really cut down some of the worst of the time, and make the job just more efficient.
Right.
There are knockoffs, but I haven't used them, or I can't really speak to them. I think the biggest thing you need to be aware of is the dust extraction. That I have found is a hallmark of a well-designed tool versus a poorly designed tool, is how much dust it gets out. Because the dust is both like an ecological concern, it's a health and safety, concern. You have to wear protective equipment, and the more dust that is created, the more you have to clean up from your site. So I can speak and say that this gets about 90 to 95% of the dust, which is huge, because you're creating a lot. But I can't speak to how anything else works, or any of the knockoff tools might work.
Okay. And so again, this is called the Paint Shaver Pro.
Correct. Yeah.
And they have different amp versions,
Mhm.
I guess, and they probably are heavier as they get up in amps.
Yeah, exactly. I went for the kind of heavy duty one because I didn't know, I'm using sort of off label, and I wanted
Yeah.
to make sure that I'm gonna at least get the best power. But I think I could have gone with a lower powered one and been okay.
Right. Okay. Yeah. And I don't, yeah. So it's about $1,000 for maybe the low end, $750 for the low end.
Yeah, yeah. Not the cheapest tool, I'll be
Right.
honest.
Well, yeah, but believe me, at any point in my short career as a painter, I would have paid that. Um, so, well, there's two great ones which we have not ever mentioned before. So, tell me a third tool that you really like.
All right. The third one is, Kevin, I think I'm going to be maybe your guest of like tools that are not that easy for people to get. This one is called Abacus, and it's finite element analysis software. And maybe I don't want to even tie it to a specific brand. Um, it could be any finite element analysis software. And as far as I know, I think Fusion 360 by Autodesk now includes a few finite element analysis package as part of
Okay, so let's start with finite element analysis and why our listeners would even want that, and what is that?
um, okay, so sometimes you want to understand how an object might behave under different physical conditions.
You're talking about actually an actual physical object.
Yeah, like a physical object. I'm going to bring out my example here, so I have something to reference. So this is a shoe I worked in. So briefly, I was I would say like essentially a lab supervisor, or maybe a project manager or a product manager for MIT, in the media lab. And one of the customers we were working with, or people we were collaborating, was Puma. And we worked on a shoe for Puma that was really unique in that it had these holes that went all the way through it. Again, The tool is determined by what your outcome is.
Right, right. So you're holding up a sneaker, and
Yep.
on the side of the sole of the sneaker are these holes. It's kind of very
They
hard to
sort of look like
describe. It's kind of
lazy feet.
crenulated, holy, looks kind of, I can't even describe it.
So the term you're looking for is an auxetic pattern.
Okay.
Auxetic patterns are a class of patterns. I'm sorry, I'm a materials person.
Yeah,
I'm not
yeah,
going
yeah.
to get into the details here. Are a class of pattern that that deform in really interesting ways. Essentially, they self-reinforce as they get compressed. And why would you want to put this in a shoe? Because the shoe undergoes a lot of different forces in its life. Sometimes a person is walking around, and particularly when they're in the shoe store, they want the shoe to feel nice and bouncy. And that's a feeling that we all love when we put on a fresh pair of shoes and the shoe is just this fresh thing and it feels like, oh, I'm walking on clouds. But when we're running or we're doing something, really hard work in a shoe, standing on it for a long time a day, we can put higher pressure on our shoe. And in that case, you need it to behave differently. You want it to be actually firmer and harder so that it can withstand that higher force and still absorb the cushion of the blow. So, where does the finite element analysis software come in? You have a really complicated pattern. And every time you make a mold or try to test this pattern with the actual shoe material, it costs a lot of money because you have to 3D print this metal mold. It's extremely expensive to do. And you're not able to validate it or test a different version. And so you really need to see, is this going to work or not before we go down the road and like build this whole thing. And you find this in engineering generally. So that's where the finite element analysis software comes in. And you can either feed a finite element analysis software a full 3D model, like an STL model, or you can even feed it a two-dimensional drawing and you can run your simulation in 2 dimensions. And that's actually really great for shoes because you just take a slice down the middle of the shoe and then you imagine the force that a runner would have when they're pressing. So you might pick, the weight of a 250-pound runner, somebody really heavy, and take their pressure and put the maximum pressure they would have on that shoe and see how the pattern deforms. And that allowed us to really quickly iterate. So instead of waiting a month to 3D print a mold, to take the mold to the tester, to inject it with the foam, to see what the foam is doing, we can get a turnaround and a validation in a day.
Okay.
So, and anybody who might be a serious engineer here is probably familiar with this, but I think it's really interesting for general makers to think about how do we simulate or validate something without having to go all the way to like find the final thing.
Okay. So let's say I'm a maker and I have a 3D printer and I have a file for something that maybe is going to try and bear a load, and I'm really concerned about it. I could still make some prototypes, but I want to kind of have further confirmation or maybe explore the possible ways to print it. So I would use this software
Mhm.
to simulate the pressures and stresses on the 3D model that I have.
Exactly. Or you might have an object that takes a lot to make the final object. Like you need to do a casting or you need to do, some sort of like really a CNC machining as an example, where it's a lot of setup and run time to figure out like, is this even going to work or not at the precision I need it? These allow you to separate, to add precise loads, to add precise forces, and to really see how things behave with the material properties. Like you could use steel or you could use foam. And most finite element analysis software kind of lets you even just add in general characteristics of materials, and then it can simulate that material.
Okay, so I am now in the market for finite element analysis software. The one that you're recommending, Abacus, is it one of many? Is it
Oh,
the
yeah.
best? And
Um,
why is it better than others?
I think it's just kind of the oldest, and at the time that I was using it, it was what was available. So MIT, through their licensing, gets access. The students get access to a lot of software, and it's kind of like everybody wants a college student who might be an engineer one day to use their
Yeah.
software because then that's what they get used to and they ask for at work. So through, Abacus is owned by the makers of Dassault, which also makes, CAD software. But I think, your big competitor is Autodesk, and they offer, sort of this freemium or like lower cost, or at least, there's a way to test out Fusion 360. And Fusion 360 is kind of like trying to become the all-in-one CAM software. So why would you use Abacus? I think it's kind of this old school like thing. I think Abacus goes back to the 80s in terms of its heritage, and it's sort of this like um, traditional version, and then Fusion 360 is kind of newer. What Abacus lets you do is it sort of lets you set every parameter. Like you can create your own materials, you can code it. It has a like like a user interface that you can like click on buttons, but it also like takes scripts and so forth. Fusion 360, I think, is newer and it is less kind of mature. Maybe a little bit more user friendly out of the gate, and maybe a little bit more documentation. So if you're a student at a college and they have Abacus, use that one for free. But if you're somebody as a maker who wants to just understand and explore finite element analysis, I would get like whatever you can get that's part of a free package, like a Fusion 360.
Right. Okay. That's really great. So I didn't know about that. That's really good to know. I do 3D print, so that's even more useful to hear about.
Yeah.
Um,
I,
and
I would I would also just say that like
is Abacus free?
no, definitely not.
Okay.
It's a again one of those, if you have to ask, it's too much, which is why I would steer
Well, we
people.
have to ask.
Yeah. I
So
mean, it's a per seat, engineering tool.
uh,
So several thousand per year is probably the
right.
cost of this. And it depends on the size of your institution and the negotiation that your business development team does. So again, I'm choosing these tools maybe more on the like, whoa, this is like a crazy thing I may never have heard of.
Mhm.
But the interesting thing is that finite element analysis has become, through, because it's used in engineering now, maybe it's becoming a little bit more available through software like Fusion 360. And, I guess the last thing I'd say is the time to really bring in some software like this is when you're doing a really, something that it's not practical to test in real life, because the cost is really high or the forces are really large. That's like really when you bring this out, is to sort of start to iterate and test on something that is just impractical to test repeatedly, or it's cost prohibitive.
Right. Right. Okay. All righty. Well, thank you for that.
Mhm.
So, Will, your last choice, the fourth choice. Uh,
Yeah. So this is actually goes back to my history, and I'm going to talk through a process again, because that seems to be my theme here. But I hope it illustrates kind of the what you could do with the tool a little bit better, or why I might choose it. And my fourth one is the I will say the Form 3 3D printer, although primarily I have used the Form 2 3D printer. So as I was going from an artist into a product designer, I started working on human interfaces with different kinds of computers, and one was 3D printers. So I joined a little startup in Cambridge, in Cambridge, Massachusetts, called Formlabs. And Formlabs makes a resin-based 3D printer. And as they started, they were really targeting the maker group, the maker space group. But over time, as they found who is really using this printer, they've moved more to dentists, engineers, doctors. So it's a pricey printer at this point. Although the Form 2 on an eBay, you can get a perfectly working one for less than $1,000.
yeah.
So
Let me just pause there and say there are basically two kinds of 3D printers. There's the original kind that used a filament that would feed into it, and it would remelt the filament and layer by layer. And as it cooled, it would make a solid object. And then the resin ones, kind of a little different one. They're more complicated, a little bit messier, and therefore more expensive. Whereas they have a liquid that they start with, a resin, and they use ultraviolet light to harden it. And it goes in reverse, where it pulls up the finished object from the liquid as it adds on layers beneath it. And generally, it's considered that the surface of the resin printed ones are smoother, a little bit more higher resolution, and so they're preferable for a higher quality 3D print. Is that
Mhm.
basically about right?
Yep. And I would say, one of the reasons you might go with a resin-based 3D printer is because the parts are fully solid. Um, and when is that really good? It's good when you want something that is, maybe moldable or castable because you don't have little holes or ridges on it that can maybe catch in your mold or that will leave a surface finish that doesn't look as nice. And so let's talk about what I did with this 3D printer. Well, I did a lot because I worked for the company and you get 3D printing for free when you work for a 3D printing company. So I made all kinds of fun objects, but I got really into a project making planters. And for a while, I was making 3D printed planters that were plastic, and I was just iterating. And all of this came about because I wanted to make a succulent planter that didn't kill my succulents. I was really terrible at growing succulents. And over time, I realized I needed a kind of planter that would allow you to water the plant from underneath. It's called a sub irrigation planter. And so I designed this planter myself and 3D printed a mold
Okay.
or a
I'm
master.
gonna I'm
Yeah.
gonna pause you for a second. You just held up a little tiny two-part planter, one um, section layers on top of the other, and the one on top has a little kind of funnel bottom. So that presumably is where the soil is and allows the water to kind of seep up from below.
Exactly.
But it looks
So
very handsome. It's kind of rectangular and
yeah.
sharp.
So this is I actually have one right here that has a cactus in it. And the cactus actually grows a set of roots down through the bottom of the planter into the little reservoir for water. And so I never get too much water on the plant and it never rots or gets too wet. And so it can take like kind of a sip of water from beneath. And that, allows me to grow my succulents and not have problems with them rotting or being unhealthy. So um, the process. I started off by thinking about how I would make these ceramic planters that are really unusual shape because they have to have, there's sort of a shape that people don't really make commonly, sort of this rectangular shape. And so the way you create unusual shapes in ceramics repeatedly is you create a plaster mold. And so the plaster mold is actually a two-part mold, and I'm holding it up to the camera right now. And it has an open end, and you can pour clay into that end, and you let it sit for a while. And the plaster mold sucks the water out of the clay and leaves this sort of skin behind. And so then you dump out the wet clay, and then that dries over time. And you can take the mold apart, and then you have your clay in the middle of the mold. And the beauty of this process is you can make really unusual forms, like anything that you've seen that's like a molded rabbit or like a pitcher. Those are commonly made by this kind of casting process. And so how did the 3D printing come into it? To make these plaster molds, I created a 3D printed original mold version.
So you're
And
holding up in one hand half of the plaster mold, and then in the other hand you have a resin printed version of it
yep,
of the opposite side, I think it looks like, or maybe.
exactly.
And so you start with the printed version. Great.
Exactly. So you take a printed version and you cast it in a silicone mold. And then you can use that silicone mold to make your plaster molds. And if if you're really clever about it, you can kind of use one mold to make two parts. So this is
Right.
actually the same part, and it's just as it's rotated, it fits together perfectly. And there are keys built into it so that the two ends mate perfectly and they're very watertight. And so the ceramic
Yeah.
can go in. And that kind of reduces the number of molds you need to make. But part of this is, you use the 3D printer to test the original design and
Right.
validate that, making sure you feel good about that. and then you use the printer to validate and to test your 3D printed mold. So, it's easy to print two versions of it and see, hey, do these fit together well or do they not fit together well? And if they don't, then I need to kind of fix something or
Right.
adjust my spacing
Right. So let's
before.
get back then to the printer, which is
Mhm.
what you are recommending. I know you may be biased because you used to work for the company, but would you say that if you were going to buy a 3D resin printer today, that this is the one that you would recommend?
I think there's this sort of weird thing in tools where you can get locked into systems. It kind of depends on how much of a if you're on the tinkerer spectrum or the like, I got to get things done spectrum. And if
Let's
you're on,
okay. So what side is this one good for?
this is on the get things done spectrum for sure.
Okay.
There are customer service plans, there's like upselling, there's like ways to automate the system. Like you can strap on this thing that like actually takes the part off the printer and like you lets you print multiple things when you're away for a
Yeah.
while. So this is definitely on the like, I need to get a lot of 3D printing done, and I don't want to mess around with the figuring out the software. But I think the alternatives are I just have less experience with, so I can't speak
Yeah.
to.
Yeah.
But if
Okay.
I and even as a maker, when I'm tinkering around, I kind of want to know something's going to work the first
Right.
time.
Right.
So
So it looks like if you buy a reconditioned one, you can get that for around $2,000. I'm not sure what the new ones cost, but there are also, by the way, fourth resin 3D printers versus the filament ones. There are additional steps and equipment needed, like you have to rinse it, you have to cure it with a light. So it is a little bit more of an expensive proposition if you're going to get into it. So it's not just the printer itself.
Yeah, I would actually, well, that's the funny part is the cleaning and the washing. That's maybe the part where I think you can find some value. Washing really is like little bit of isopropyl alcohol or rubbing alcohol in a bucket. And in terms of curing, I would just put these in my windowsill and let them, once they were nice and clean, I would let them sit in the sun for a little while. The sun provides a lot of UV rays, and that really hardened them up without causing any, because they're pretty solid pieces. It wasn't something I was worried about. If you had a very thin or delicate piece, you might not want to leave it in the sun for too long because it kind of will get how do I describe it? It'll become brittle over time. As the sun really cures and makes that plastic very hard, it's easy to like snap off little pieces. So, just kind of like anything is like a bit of a process or experimentation.
Yeah. But anyway, so this is the Formlabs 3 that you are suggesting. Is that right?
The Form 3 3D printer. Yeah.
Yeah. And so I do know friends who have that version for even as a first 3D resin printer. So um, it would certainly be a candidate if you're looking at one.
Mhm.
So, Will, we have a few minutes left. Why don't do you have a project that you're working on or a cause that you'd like to share with our listeners?
I'll be honest, as a dad of a 2-year-old, and somebody who took on a massive home renovation. Right now, I got no extra time, and also, working on this future of voice AI
Uh-huh.
conversational interfaces. But I live in the Bay Area, and one thing I've noticed is that it's just really hard to connect with people. Unless you're talking to people through work, it's just, and maybe this is a new dad thing as well. So I guess I would say if people want to reach out through my Instagram page or my LinkedIn page, I'd love to just chat about making stuff, meet up for coffee, or if you've got kids like needed a playground, talk about making things, or even just recommendations for good maker meetup groups because that's been a little tricky to find.
Yeah.
So I'll just call out my Instagram profile, and people can reach me through that.
Yeah. And I don't know, since you are the Bay, you might have heard that they are going to resurrect the Maker Faire this month.
Oh my God, I'm so excited.
Yes, yes.
I've been very tuned out.
Yeah. So that is happening. Well, actually, this month, I think it's October. Um, Check it out. It's going to be on, I think, Yerba Buena Island. I don't remember, but in the Bay Area, in the East Bay, there's going to be a Maker Faire for 2 different weekends, and Friday, Saturday, Sunday for both weekends. So plenty of time to go visit, and you can meet your tribe there.
What an enchanted place. I have the fondest memory of Maker Faire 2015. It was just the epitome of 3D printing, and there was a company that had a robotic pour over station. They were making pour over coffees.
Yeah.
What a magical experience. Can't recommend that enough.
Yeah. We'll see if they're able to resurrect the magic of old. But hopefully they can. And again, for listeners in the Bay Area, you should definitely seek it out. I like Will in the past, they have been incredible in terms of things to see, things to do, stuff that kids love, and whole new ways of doing things. And then just the whole maker spirit of people who are really passionate about doing things themselves. And so highly recommend that.
Outstanding. Well, thanks for sharing.
So, Will, I'm really delighted. You kind of took us on a little different path, which is really welcomed. And I love your interest in material science, which is something that as you make things, you become more and more interested in, because you realize that these things have properties, and the better you understand the properties and the possibilities, the more fun you can have. So thank you for taking time. And we'll have your Instagram or others in the show notes if you provide that to us. So thank you.
This was a delight, and I have enjoyed your voice, your guests, and your recommendations for years. So thank you for reaching out and including more people.
I'm really delighted. Best of luck on your AI endeavor and your art as well. I can see behind you there's a little bit of some artifacts, and that's always a joy to see those. This year, our Cool Tools blog will be 20 years old, which means we've been posting something new every day for 20 years. It's only possible because of the very engaged and knowledgeable readers and listeners like yourself. You've kept this place going, and we are very grateful for you. With this idea of 20 years in mind, we decided to try an experiment this year, and I'm inviting our guests and listeners to join me on our Cool Tool Show and Tell, which is the program that you're listening to right now. So if you feel you'd make a good guest on this podcast and have 4 uncommon tools that you'd like to share with us, please sign up on our form on the website, and we'll see about inviting you. You must be comfortable talking on a video, and you need to have some tools that you can show. We record on, as you know, on Zoom. We do a YouTube version, a video version of it, as well as an audible version. Fill out the form if you're interested, and list your 4 cool tools, and we'll see if there's a good fit. The applications aren't guaranteed in any way, and we're looking at tools that are new to us and appropriate tools, and whether the times will work for you. So we're really interested in hearing from people all over the world, not just in the US, although the tools have to be available online, easily available online. And if you are a longtime listener, you kind of know what the definition of our tools are. They're very broad. They can be anything that's handy, from something in the kitchen to something you use to travel, to a workshop, to something professional that we may not know about. We're really interested in things that we don't know anything about. So this is an open invitation. We'll give it a try. If you think you make a good guest for this podcast, fill out the form. There'll be a link somewhere on our website, and We look forward to chatting with you. Thank you.